Hi students, so now we will be solving this particular problem. The problem is integration of e to the power 3 log x into x to the power 4 plus 1 whole to the power minus 1 into dx. Alright. Now, few videos back, I told you about a concept in log, actually about two concepts in log, now which we will be applying here directly. So first we can break this problem into this format because this is x to the power 4 plus 1 whole to the power minus 1. So we can write this as 1 by x to the power 4 plus 1 whole to the power 1, right? I hope this concept of power is clear to you, that we can write 1 by x as x inverse or x to the power minus 1, or we can write x inverse or x to the power minus 1 as 1 by x. Okay, now looking into this particular problem, I hope you understood what I said. I can write x inverse as 1 by x. Here x is nothing but x to the power 4 plus 1. Okay, now and the reverse is also true. We can write 1 by x as x inverse. Okay, because when this power 1 x goes in the numerator, this power becomes a minus. Okay, all right. So now looking into this problem, I told you that whenever you have this particular format like e to the power 3 log x, you can take this 3 on the power of x. How? You can write this thing as e log x cube divided by x to the power 4 plus 1 into dx. Okay, in case you missed out, I'm telling you now that you can write this 3 onto the power of x. Okay, when you have such a format for log. All right, now the next step is this one also I told you that here we have a log base e, right? When you have nothing mentioned, then you take the base of log as e. So whenever you have e to the power log base e x cube, then you can write this entire thing as simply nothing but an x cube. Do you remember I told you? Okay, now I take the integration of this particular thing. Now can you understand that we can solve this problem by substitution only? How will you figure out that we can solve this particular problem by substitution? Mentally try to calculate initially, okay, that if we take the derivative of the denominator, then we get the numerator. Okay, so if I take the derivative of the denominator, I'll actually be getting 4x cube plus 0 or 4x cube right? So if I get 4x cube, which means I have an x cube here, so x cube is there in the numerator, right? So now how will I be doing it? Let's see. Now putting, say, x to the power 4 plus 1 as t, I will be getting 4x cube dx is equals to dt. And I have an extra 4 here, right? So x cube dx, that is what I have to replace by 1 by 4 dt. This 4 has to come in the denominator because I'll be replacing this, right? So in this particular question, in place of x cube dx, I can replace that by 1 by 4 dt, and I'll replace x to the power 4 plus 1 by t as mentioned here. So what will I be getting? Integration of 1 by 4 will come outside of the integration sign as it is a constant, and inside of the integration sign what we will be getting? Inside of the integration sign we will be having 1 by t into dt. Alright, and we are well aware of the formula for 1 by t, integration of 1 by t dt, which is nothing but log of mod t plus c, right? and this will become log of mod x to the power 4 plus 1 plus c. We can write this as log of x to the power 4 plus 1 plus c. Now you might be asking me that why have I used a curly bracket here? I mean a bracket here, not a curly bracket, a bracket here, right? There was no need to, because we know by the formula that it is log mod of the particular function plus c. But instead of putting this mod function, I put this particular bracket. Why is that? I did that because x to the power 4 plus 1 is always a positive function. It can never be negative because it is actually in this particular format. You can write 4 as x square whole square, right? And we all know that square of any particular function is always greater than 0, of course, keeping in mind that x belongs to any real number, okay? Keeping in mind that x belongs to any real number, if I take any real number, then the square of that number will always be positive. So inherently x to the power 4 plus 1 is positive. So no need to mention the mod sign here, okay? So we can just ignore the mod sign here, as x to the power 4 plus 1 is inherently a positive function. I hope this is clear to you. X to the power 4 plus 1 is always greater than 0, keeping this particular condition in mind. Alright. Now, we will move on to the second problem, which is very easy actually. It might look a bit big, but it is not. Into so the particular problem that we have here is integration of 3 to the power x plus tan inverse of x. This entire thing is in the power of 3 multiplied by x square plus 2 divided by x square plus 1 dx. Now how will we solve this particular problem? Now roughly you can make out the fact that if I take this power, that is x plus tan inverse of x, as t, and then if I take the derivative of it, I will be getting a number which is like, I will be getting this thing roughly. Now I'll tell you why and how, okay? So let's see. Let's first consider this particular function as t, and then when we take the derivative of x is nothing but 1. The derivative of tan inverse of x is nothing but 1 by 1 plus x square whole of dx equal to dt. Alright, and then what we get in its place here, if we take the LCM and all, then x square plus 1 is the LCM, right, in the denominator, and in the numerator we have x square plus 1, which is nothing but x square plus 2. Did you get the form roughly now? Yes, I hope you did, right? This entire part will be replaced by dt, and this x plus tan inverse of x will be replaced by t. So it is as simple as that. So when I solve this particular problem from here, what I get? I get 3 to the power t, right, and multiplied by dt. Did you get the particular thing? I hope you did. I just did nothing, just properly substituted, okay? And as I arrive here, how will I integrate this? This is in the particular format of integration of a to the power x dx, right? And what is the integration of a to the power x dx? It is nothing but, tell me what it is. It is a to the power x by log of a, right? What is our a to the power x here? 3 to the power t. And what is our a here? 3 plus c. As I told you in the previous problems also, that it is very important for you to remember replacing the variable that you have considered in order to simplify the problem. In case you forget to do that, you will lose out on your marks. Okay, so these two problems I most particularly did because in order to show you that sometimes in integration you might have, you know, these big kinds of expressions and you might feel that it is very hard, which it is actually not. One substitution solves the entire problem. Okay, and this particular formula, that is integration of 1 by x dx is equals to log x plus c, will find a lot of log of mod x plus c will find a lot of usage in the upcoming videos or upcoming problems that I'll be solving. Okay, so these were the two problems. If you really like watching my video and if you get any benefit from it, then please don't forget to like, share, subscribe and hit the notification bell icon for more of such exciting content. I hope you guys are enjoying integration a lot. All right, and I am enjoying my teaching also actually. Okay, so now let's move on to the next video.